So the next question is 4 charges plus Q, minus Q and minus Q respectively are placed at the corners A, B, C and D of a square of side A. The electric potential at the center O of the square is dash. Okay. So now we can go for a square. Okay. So let us consider this may be the square. The corners of the square, it may be A, B, C and D. At A, B, C and D, the charges minus Q, plus Q, minus Q are placed. So at A, plus Q, at B, plus Q, at C, minus Q, at D, minus Q. Okay. At the center O of the square. So which may be the center of the square. So when we join the diagonals intersect at a point. That point is taken as O. At that point O, what is the electric potential? For this I am going for 2 solutions. Now we can consider A and C. Then it may be minus Q and plus Q. Minus Q and plus Q. Then we can say it is a electric dipole. Okay. So when we are consider the electric dipole, now only we studied the potential P cos theta by 4 pi epsilon 0 into R square. At this point, so where it makes 90 degree, cos 90 becomes 0 into something 0. So the potential at O due to AC is 0. Okay. Now we can go for BD. So BD. Once again we are having positive and negative. Once again it acting as a dipole. So finally we can go for the potential is 0. So the net potential at the center is 0. Okay. The same question they may be asked plus Q, plus 2Q, plus 3Q, plus 4Q or minus Q, minus 3Q, minus 4Q. Like that, when they are asking like that, then where we can solve the problem. Okay. So let us consider a square of side A. Then what about this distance? It can be taken as A root 2 by 2. A root 2 by 2. So from the midpoint to the diagonal, is A root 2 by 2. Or by using the Pythagoras theorem, you can find the value. Okay. So due to the positive charge which is placed at A, it produces electric potential at the point. So point charge produces the potential B equal to 1 by 4 pi epsilon 0 Q by R. Okay. So due to the positive charge plus 1 which is placed at A. So V1 equal to 1 by 4 pi epsilon 0 plus Q by the A root 2 by 2. That can be taken as R. Okay. So R. The plus Q which is placed at B, it produces the potential is taken as V2. That is 1 by 4 pi epsilon 0 plus Q by R. So minus Q is the charge placed at C. It produces the potential V3. That is 1 by 4 pi epsilon 0 minus Q by R. So another charge minus Q is placed at D. V4 equal to 1 by 4 pi epsilon 0 minus Q by R. Now we can add all the potential V1 plus V2 plus V3 plus V4. Now in all the terms we are having 1 by 4 pi epsilon 0 as a common. Yes. All the terms we are having Q as a common. Yes. In all the terms we can have R as a common. So Q by R. So by taking all the terms we are having plus 1, minus 1, minus 1. Now plus 1, minus 1, plus 1, minus 1, it becomes 0. So 0 into something, it becomes 0. So the net potential at the center of the square, by plus q, minus q charge configuration, it produces zero potential. Okay, do you get it now? Do you have any doubts? Okay, no doubt.